In the topic applications of derivatives, we have discussed how to check the given function is increasing and decreasing. Okay, so that part is completed. Now we will continue with that. Last time we have solved that exercise which is given. So see here, uh, we have to find out the values of x such that f of x is decreasing function. This is question number 3 from the exercise 4.2. Okay, last time we have solved to find out the values of x such that f of x is increasing function. Now today we are going to solve, or we have to find out the values of x such that f of x is decreasing function. We know that the function is said to be decreasing when f dash x is less than 0. So you remember this and try to find out the values of x where the function is decreasing function. So let us see. Now see here, first function is given f of x is equal to 2x cube minus 15x square minus 144x minus 7. Okay, now see in answer how will you write? First of all, given that, here write down the given function, that is f of x is equal to 2x cube minus 15x square minus 144x minus 7. Now from the given, as this function is decreasing, as f of x is decreasing function, as f of x is decreasing function, that means we know that f dash x, that means we know that f dash x is less than 0. So this is given to you, f dash x is less than 0. Now we will continue with this step. So find out f dash x. Now derivative of 2x cube. So we get 6x square minus 15x square. Derivative of x square is 2x. So 15 into 2 is 30x minus derivative of 144x. So here it is 144 because derivative of x is 1 minus derivative of 7 is 0. So it must be less than 0 for all values of x. Okay, now we have to find out the values of x on the real line where this function is decreasing function. Now if you see this equation, then here you can take 6 common, and means if you divide the both sides by 6, then what will you get? For simplification you will get x square minus 5x minus here 24, which is less than 0. So dividing by 6, we simplify that equation. Now to get the values of x for which the function is decreasing, we have to solve this quadratic equation. Okay, so by usual method we will solve this. So this is 5x and this is 24. So we can write it as minus 8x plus 3x minus 24 less than 0. So minus 5x is written as minus 8x plus 3x. Now from the first two terms you will get x common, and in bracket you will get x minus 8 plus from the second two terms we get 3 common, and in bracket x minus 8. So that's why you will get two factors of this quadratic equation. One is x plus 3 and other one is x minus 8, and the product between these two linear factor must be less than 0. So this is the condition that we have to follow because the function is decreasing function. Here x plus 3 into x minus 8 less than 0. Now see here, x plus 3 and x minus 8 are two real numbers, and product between real number must be negative. So what will you do? We have to consider two cases, because see I will write here, to get the product between two real number, uh, that is negative product, we require to consider the case number 1. Case number is what? First of all, we will consider that x plus 3 is less than 0, and at that time x minus 8 is greater than 0. Means if you consider one number negative and other number positive, then negative into positive is always negative. So this is the first case. Okay, so now by which you will get, now as here x plus 3 is less than 0, we have to write x less than minus 3, and at that time x must be greater than 8. From x minus 8 greater than 0, you will get x greater than 8. Now we have to find out the all the real numbers which are less than minus 3 and greater than 8. So is it possible here? Means number which are less than minus 3 and the number which are greater than 8 are not possible. Okay, so this condition is not possible. Okay, so you have to write that this is impossible, because there is no any real number which is less than minus 3 but greater than 8. So but we have to consider the case as per the requirement, but you have to write that this is impossible case. Okay, now we go to the second case. Now in second case, what we have to consider? We will consider that x plus 3 greater than 0 and x minus 8 less than 0. Means here we consider that one number, that is x plus 3, we consider it as positive and x minus 8 as negative. So positive into negative, again you will get negative. So this is also possible case. Now from which we get x greater than minus 3 and x less than 8. So we have to find out the real numbers which are greater than minus 3 but less than 8. So here this condition is possible. So what will you get? We require the number where x belongs to greater than minus 3, means to the right hand side of minus 3 on the real line. So minus 3 to 8. So we get the values of x for which the function is decreasing function, because the value between minus 3 to 8, if you take the values of x, and then in that interval you will get the function is decreasing. So you can write the answer as, from case number 1 and case number 2, we will complete the answer as the given f of x is decreasing, when x belongs to minus 3 to 8. So this is our last answer. So first of all, you have to consider that f dash x is less than 0. Then taking derivative, you have to solve the equation, and as you get two factors, you have to consider, to get the product negative, you have to consider one number negative and other number positive. And then case number 2 as one number positive and other number negative. So positive into negative becomes negative. So that's why there are two cases in which case number 1 is impossible on the real line. So you have to mention that it is impossible, and from the case number 2 you will get the interval on which this function is decreasing function. Okay, so try to solve this question. Now let us see, another function is given. Okay, and we have to find out the values of x where this function is decreasing. So first of all, I will write given that f of x is equal to x raised to 4 minus 2x cube plus 1. Again the given that f of x is decreasing. So we have to consider that f dash x less than 0. Okay, now from this condition that f dash x is less than 0, first of all find out the derivative. Derivative of x raised to 4 is 4x cube minus 6x square. See here, derivative of minus 2x cube, derivative of x cube is 3x square, so 3 into 2 is 6x square, plus derivative of 1 is 0, so no need to write, which is less than 0. Now we have to solve this equation, but here from these two terms you will get x square common into bracket 4x minus 6, which is less than 0. Now see, the product between x square into 4x minus 6 less than 0. So here mathematically if you observe this, then x square is always positive. So this is a positive number. Okay. So 4x minus 6 must be less than 0. So there are two factors. One is x square and other one is 4x minus 6, in which we required 4x minus 6 less than 0 because x square is always positive. Okay, so from this we can write 4x minus 6 must be less than 0. Okay, now we have to solve this. So we get 4x less than 6 and hence we get x less than 6 upon 4, or by simplifying we get x less than 3 by 2. So the given function is decreasing on the real line when x is less than 3 by 2. So you can complete the answer like this. So given function, given f of x is decreasing, given f of x is decreasing when x less than 3 by 2. So you can keep this as a final answer. See here we get the two factors, that is x square into 4x minus 6. So you have to consider that 4x minus 6 is less than 0 and that's why you will get x less than 3 by 2. Okay. So the answer is depends on the factors that you required from the derivative. Okay. So see this answer and you have to write that x less than 3 by 2 on the real line. Now see the next one, that is f of x is equal to 2x cube minus 15x square minus 84x minus 7. Now here it is given that given f of x is decreasing on the real line and we have to find out the values of x on which this function is decreasing. So let us consider that f dash x, or it is given that f dash x less than 0. Now take the derivative of the function. So here you will get derivative of 2x cube, that is 6x square minus 30x minus 84 less than 0. Check the derivative of every term. Derivative of 2x cube means derivative of x cube is 3x square. So 3 into 2 is 6x square minus 15 as it is. Derivative of x square is 2x. So 15 into 2 is 30x minus derivative of 84x. 84 as it is, derivative of x is 1 minus 7. Derivative of 7 is 0. Now again here you get the quadratic equation. Take 6 common and divide. So here you will get x square minus 5x minus 14 less than 0, dividing by 6. Now solve this quadratic equation by taking the factors of the middle term. So x square minus 7x plus 2x minus 14 less than 0. See the factors here perfectly. So from the first two terms you will get x common plus, see the factors. So hence we get two linear factors. One is x plus 2 and other one is x minus 7. And product between these two factors must be negative. So as like the first example that we have completed, we have to consider here also two cases, because the function is decreasing, that's why f dash x is less than 0. So we have to consider the case number 1. Case number 1, that x plus 2 suppose negative, then we have to take x minus 7 positive. Now from which you will get x less than minus 2 and x greater than 7. Now we have to find out the number where x is less than minus 2 but x must be greater than 7. Now think on the real line. This is not possible. So this is not possible, or you can write impossible. Okay. There is no any number which is greater than 7 but less than minus 2. So this is not possible. Then you have to consider the case number 2. We will consider the case number 2 as x plus 2 greater than 0 and x minus 7, at that time x minus 7 less than 0. So here first number is positive and other number is negative. So from which we get x greater than minus 2 and x less than 7, like this. So on the real line, we require the number which are greater than minus 2 but less than 7. So this is possible. So how will you write in the interval form? X belongs to minus 2 to 7, like this. So hence we can write the final answer as, so given f of x is decreasing when x belongs to minus 2 to 7 on the real line. Okay, so this is the final answer. So in case of decreasing function or in case of increasing function, you have to consider the condition that is given, that for increasing function f dash x must be greater than 0 and for decreasing function you have to consider f dash x less than 0. Take the derivative, see the factors and then decide on which that function is either increasing or decreasing as per the given. Okay, so try to solve this exercise. Thank you.